Hello everybody, and welcome to our first lesson of the school year. I'm calling this lesson 2.0, Dimensional Analysis. And you can see here we're going to use dimensional analysis to solve the following and check that the units and calculations are correct. Now, the key word there being dimensional analysis. Dimensional analysis is talking about the number's dimension, or by dimension we mean the label on or attached to a number. Okay, so for example, my first example, 3 meters. The meter is the label. The meter is the dimension of the number. We are trying to convert the meter dimension to an inches dimension. And so using this, we need to use our dimensions, use our labels as we work through this. Okay, in reality, those of you that are thinking about this problem, what I'm going to put in this place right there is not a challenge. The challenge is not getting the number. The challenge is showing the dimensional analysis of it. Okay, so I'm going to erase this and we'll fill that in. What I would do to start is I first start by writing down the number that I have, 3 meters. If you're a person who likes to do this, to make it perfect and make it have all the dimensions, it's 3 meters over 1. All right, and now you're going to use your unit conversions. So there's a conversion sheet attached to this lesson. You want to look at that and have your conversions if you don't know what they are. And now obviously to go from meters to inches, I need to have a conversion. So on that conversion chart, it says 1 meter is equal to 3.3 feet. Now, we're not going to use this as an equation. We need to use this as a fraction. So what that means is I have either, this works either way. So I can write it as 1 meter over 3.3 feet, or I can write it as 3.3 feet in 1 meter. So when there's two options to use, option A here or option B over here, when there's two options, you have to figure out which one it is. So every one of those things on the unit conversion sheet has a sentence like this, and you either use version A or version B, okay? Now, which one do you know? Well, what I need to do is I need to get meters turned into inches. So that means meters has to be canceled out. So is option A or option B going to cancel out meters with this 3 meter here? And the answer is option B, because if I write this down, I'm going to write 3.3 feet over 1 meter. Now if you look here to see how the meters will cross out, leaving feet. Now I know feet isn't our final answer, but then I can keep converting from there. So the next thing is now I need to get from feet to inches. All right, and I hope we all know this conversion, so I could write it again. It's 1 foot would equal 12 inches. Okay, so that means I could either have 1 foot over 12 inches or 12 inches over 1 foot. And again, the purpose is I need to take feet and cross it out with something down below. The only thing that cancels out feet will be feet, so I have to have the label of feet be in the denominator right there. So I'm going to bring that 12 inches over 1 foot up, and now I have it there. And then what I'll do is it's multiplication, and the way we multiply fractions is just straight across. So multiply the numerators and I multiply the denominators. Well, then that's going to be 3 multiplied by 3.3 multiplied by 12. You can use a calculator, and now notice that all I have left, the only label left for me is inches right there, and so that's the label I will use, is inches. And 3 multiplied by 3.3 multiplied by 12 would be 118.8 inches, and then that would be my answer. Again, it's not hard to come up with that number. The thing I'm challenging you with is to do all of this dimensional analysis here that I did. So basically it's like you need to show your work. All right, without this work, you will get no credit for the problems that you complete. So please make sure you do that. All right, before I move on to my next question, I'm going to clean up my workspace here a little bit and give us some more space. All right, now that I have a cleaner screen, I'm going to move on and I'm going to start with 14 miles. So again, to begin with, I want to first start with just the dimension I'm given, which is 14 miles, and I'm going to just write that over 1. And some of you in your science classes maybe have done this dimensional analysis already, and you like the way they've done it better than what I did here. I'm just going to show you a different way to show your work, the tiny bit. It's not a big difference, but just so you can see there's more than one way to go about it. I'm going to multiply that by my first conversion, and what I'm going to use as my conversion is miles to feet. And so again, you can look at your conversion sheet, and on that sheet it says that we know 1 mile is equal to 5,280 feet. So then again, we'd use two options, option A or option B. One option is 1 mile over 5,280 feet, or 5,280 feet over 1 mile. So again, it's just pick which one of those are going to work, which one is going to cross off with the miles, and that will be this one right here. And so I'm going to bring that conversion over here and put it right there. Okay, so we'll do that, but I'm going to do it in a slightly different way, very minuscule difference. All right, so there you see I wrote it in there. This time I put it in parentheses, slightly different, but not a big difference, and then I can cross off the miles. And now that the miles are gone, my final dimension then is in fact feet, and that's what I need it to be. So I am done. I can just simply answer the question, and so then now I multiply straight across, and that's going to be 14 by 5,280. Again, you can use the calculator. That would be 73,920 feet are there in 14 miles. And again, this number is not a challenge to come up with. The challenge we're doing on this is to use the units in our work. Now I'm going to move on to my last example here, which I'm going to start with 4 hours as my number. And if you have done this in science yet, they like to make just a long table, and they kind of make it broken down here. So then it's just simply 1 down here. And then I now need to convert from hours into seconds. The conversion I know is that there are 60 minutes in 1 hour. All right, so then again, is that 60 minutes per 1 hour, or is that 1 hour over 60 minutes? Okay, so again, it doesn't matter which way you write it, you just have to use the one that works the best. And which one is going to cancel these hours? And that will be this one right here. So 60 minutes divided by 1 hour will cancel out hours. And then we put our line down right there, and now I need to convert from minutes into seconds. So now I know in 1 minute there are 60 seconds. So I have to put 1 minute somewhere and 60 seconds somewhere. Well, I know for a fact that I'm going to have to put 1 minute on the bottom to cancel off with that minute. So then I must put 60 seconds on the top. And then that is the end of my conversions. And now I know for a fact that I have seconds left over. I then will multiply straight across. So I go 4 times 60 by 60, and that number happens to be 14400. So that's 14,400 seconds in 4 hours. All right, that is the dimensional analysis. We'll keep trying this, but remember, the answer is not the challenge. The challenge is doing the dimensional analysis. Notice every number I wrote down has a label on it and has a conversion below it. So it's a lot of fractions here, all right? So with this work that we've just done, I want you to go to the worksheet that we gave you today, and I just want you to try the front side of it only. That'll be your homework assignment. As you see here, here's your homework assignment, front side of dimensional analysis. Good luck.